Okay, everybody, this is the Chapter 7 review for geometry. We're going to go through this one by one. I'm going to explain the beginning ones pretty carefully, and then if they switch up types or anything, I'll do that. But for the sake of time, if there's a lot of the same type of problem once I explain it once, I am going to shorten the explanation. Again, feel free at any point if you want to rewind it, or reverse it rather, go back, watch the same problem again. If you're not under something why I'm doing something, email me, come by at lunch, after school, whatever. Just be ready for the test. Make that choice to be ready and do what you got to do to be ready. So number one, these are all proportions, this first set. And so what we're going to do for all the proportions is use the cross product property of proportions. Cross product property. I'm not sure what's going on here. Okay. So anyway, hold on. So we start off with A over B equals C over D. The cross product property then says that AD equals BC. So we're going to do that for number one. We have B over 7 equals 3 over 2. So we're going to have 2 times B equals 7 times 3, or 2B equals 21. Now we divide both sides by 2. And we get B equals 10.5. And if we went 10.5, we want to double check 3 over 2 equals 1.5. 10.5 divided by 7 is also going to equal 1.5. Number 2, we're going to cross multiply. So again, use the cross product property. We're going to go 4 times 10 equals 2 times P. Multiply that out, we get 2P equals 40, which gives us P equals 20. We got that by dividing both sides by 2. Now we're going to kind of switch it up for number 3. Same numbers, just different order. So we have 4K equals 2 times 10. That's 4K equals 20. Divide both sides by 4, and we get K equals 5. 4, same thing. 10 times X equals 8 times 7. 10X equals 56. We're going to divide both sides by 10, and X equals 5.6. So here on 5, it's going to be a little bit different. Now, instead of just having one number on the numerator, one number on the denominator, now we have a binomial, 2 terms up on top. Now we're still going to have 7 times B, but now instead of 9 times 4, 9 times 5, we're going to have 9 times B plus 6. It's going to give us 7B equals 9B plus 6. I'm going to subtract 9, or 54. I'm going to subtract 9B from both sides. This is going to give us negative 2B equals 54. Divide both sides by negative 2. And we're going to get B equals negative 27. For number 6, same general idea, cross multiply. We're going to get 8 times n equals 3 times n plus 4. Distribute the 3, and we're going to get 3n plus 12. Subtract 3n from both sides, and we get 5n equals 12. Divide both sides by 5. We're going to get n equals 12 over 5, or we can also do it as 2.4. Make sure you have all this right. Ideally, what I want you doing with these is not just fast forwarding to the end of each slide, copying down the answers, but rather trying the best by yourself, using this as a way to check to make sure you're getting the right answers, or at the very least, only going to it once you're stuck and you need to know how to progress forward. This is not meant as a way to kind of replace the past several weeks of instruction. Rather, this is just kind of a quick review to help you prepare for the test. Moving on. 7 and 8, same general idea. Cross multiply. So we get 6 times m equals 8 times m plus 4. Minus 4, sorry. That's going to give us 6m. Distribute that 8. We get 8m minus 32. Let's subtract 8m from both sides. It's going to give us negative 2m equals negative 32. When we divide by negative 2, we're dividing a negative by a negative, so we're going to have a positive answer, 16. Repeat for number 8. 9 times a equals 10 times a plus 3. Gives us 9a equals 10a plus 30. We're going to subtract 10a from both sides. That's going to give us negative a equals 30. I'm going to multiply both sides by negative 1, and we're going to get a equals negative 30. Okay? Make sure you got that. Moving on. So, next one. They are all multiple choice. So it says state if the triangles in each pair are similar. If so, state how they are similar and complete the similarity statement. So let's look at number 9. Okay? 9, we have 2 parallel lines. And that means that angle T right there and angle, so it's JTS and JLK, are going to be congruent because they're corresponding angles. Remember, whenever we have 2 parallel lines, in this case ST and KL, that are crossed by a transversal, JL, the corresponding angles are going to be congruent. So here we use that, T and L are congruent. Both triangles, JTS, JLK, share angle J, so we have angle similarity. We don't have to worry about order here because there's only one angle similarity there. Okay, 10's tricky. Okay, 10's tricky because, okay, so let's look at this. Look at our answers. We have either side angle side similarity, not similar, or side 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 similarity. Now we know it can't be side 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 similarity. It can't be not, well, it can be not similar. But so what we're really going to look at is side angle side because we have that angle. So now we need to figure out, let's look at this. It says RST and STR. Now notice on the top triangle, the 12 is the long side, the 8 is the short side. On the bottom triangle, the 12 is the short side, and the 18 is the long side. So if we're going to be doing this, we want to make sure that we're setting it up right. Because if we set it up wrong, we get 12 over 12 equals 18 over 8, and that's not true. Now, this could be not similar, but we need to make sure that we're setting it up. So if we go short over short equals long over long, and then reduce both of those, lo and behold, we get 2/3. Out of the left one, 8 over 12, I factored out a 4. The right one, I factored out a 6. So those are the same. They are proportionate. So remember, that's what side angle side similarity says. It says if the angle of one triangle is congruent to the angle of another triangle, and the sides which form that angle are proportionate, then the triangles are similar. So we've got that done. So we have similarity. Now we just need to make sure that we are matching it up. So if we look at where that 12 is, that's FH. Okay? So FH is 12. It needs to match up to the TR. So that's going to be the top one. Okay? B, C, D. So here we definitely have a common angle. Okay? And that's going to be B, B. Okay, so again, we're looking at side angle side similarity. So really what we're going to look at here is this statement true? We can't have side 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 similarity because we have nothing relating these two sides to each other. Okay, so if we set it up, so we need to go short to short, long to long, right? So we're going to set up 25 to 15 equals 51 to 30. So 5 to 3 equals 17 over 10. Not true. Now here's the other thing. We can look just at this. Now notice that BCD, B to D, that's right here, this is 25. And then down on the similarity statement it says FBE. So first to last would have to be really the proportionate. That's FE. That's this side right here. We don't even have a match for that. In order to actually set up similarity with side angle side, we need to be including the two sides which form the angle. Now BCD, so we would need here, here. Now if I were to flip that around and if I were to go, so this is no, but I'm just showing you that it doesn't work and kind of why it doesn't work. Okay, moving on. 12 is also not similar, and here's why. We have no side lengths, okay? So we're only really looking at angle-angle similarity. Now the only angles that we're told is this 86 and this 84. Well, because we know that those are different, we know that QR and TU are not parallel. See, not parallel. Wrote the parallel sign and then X'd it out. That tells you it's not parallel. I can do it in red too. See? Super not parallel. Okay. So then, because those aren't parallel, the only one I know that both of them share is V, and without knowing any of the other angle measures, I just can't. There's not enough information there. So, moving on. So these next ones, so these are all our RTDTs, right? Right triangle division theorems. So we have our main triangle, which is right there. Now, if those are what you're given, okay, with the altitude and everything, is an altitude problem. Now, you guys should have this in the notes. It was up on the board for over a week. So, the question here, hold on just a second, is this a red triangle or a blue triangle question? Now notice what I did here is I copied it and rotated it. So here we have 925. We have the entire hypotenuse, that's 25. We have the segment next to the red leg, and we have the red leg. So this is going to be a red triangle problem. So that sets up as AC over AB equals AB over AD. Because remember, the second corollary, and this is what this is. It's important to remember that the actual rules don't just say red triangle, blue triangle. They don't say anything about it. What they do say, and the red triangle, blue triangle is kind of our interpretation of it, or my interpretation of it, which hopefully helps. But what the actual corollary says is that the leg of a right triangle, so this divided by the altitude of the hypotenuse, is the geometric mean of the original hypotenuse and the segment of the hypotenuse adjacent to that leg. So that leg right there, X, is going to be the geometric mean, that means it's going to be in that AB spot, of the entire original hypotenuse, 25, and that segment of the hypotenuse right next to the leg, 9. And that's what gives us the red triangle. So we go 25 over X equals X over 9. That's going to give us X squared equals 25 times 9, or 225. Square root both sides, and we get X equals 15. Now notice that we also need to go back and figure out that missing angle. So it's important to go back and do that. So for 14, again, red triangle. So we're going to go AC over AB equals AB over AD. Now here we're not given all of AC, but we are given its two segments. We know from way back when, segment addition postulate, if that we know what AD is, and we know what DC is, then we can add those two together to get AC. And that's 169 here. So we go 169, that's our AC, over x equals x over 25. Now here what I'm going to do, and this is actually what I erased back on the first page, somehow it got here. I'm going to go 169 times 25. And that's going to give me 4,225. So for some reason this got jacked back to the first page. Nope. Okay, so we have x squared equals 4255. We also have x squared equals 25 times 169. So I'm going to show you how I do it because I didn't use a calculator here. But if I square root both sides, so this is 4225. Now notice here, this is x equals the square root of 25, 5, times the square root of 169, 13. That's going to give me x equals 65. If I plug this into a calculator, I get x equals 65 when I do the square root of 4225. So, moving on. Number 15. This is an altitude problem, okay? We don't know the altitude, and we are given the entire thing. Now we know that the altitude problem states that the altitude, x, is the geometric mean of both segments of the hypotenuse, okay? So we use 25 and 169 segment addition postulate to figure out that 144. So here, we're going to get 144 over x equals x over 25. X squared equals 144 times 25. So I'm going to square root both sides. And again, I know that 144 and 25 are perfect squares. You guys have calculators, so just plug it in. So this is going to give me 12 times 5, or x equals 60. So notice on the next one, 16, same general idea. We need to find that missing piece of the hypotenuse. So we got 100 minus 64, that gives us 36. So we're going to go 64 over x equals x over 36. Cross multiply, we get x squared equals 64 times 36. Do the square root of both sides. It gives us x squared equals square root of x squared equals the square root of 64 times 36, or 8 times 6, or 48. Keep moving. So that was another altitude problem. This next one up, we're going to rotate it that way. Oops. Rotate it that way. That's going to show us that it is a red triangle problem because it's that left-hand triangle once we put it up the same orientation. So that's going to give us AC equals AB over AD. Now notice here that our x is the entire hypotenuse. So how did I know it was a red triangle problem? Well, when I sit there and I have kind of the generic triangle that we have up on the board, and this is my red triangle, and this is my blue triangle. So my red triangle relates this leg with this portion and the entire hypotenuse. Now notice down here, that's what we're given. Right leg, or left leg, left segment, and the entire hypotenuse. So even though it's the hypotenuse that we're missing instead of that red leg, we are still going to use the red triangle because that's what relates those three measurements together. Cross multiply, we get 36x equals 3600. Divide both sides by 36, and we get x equals 100. On to 18 again, rotate all the way around. It's another red triangle. So we're going to go AC over AB equals AB over AD. That is x over 15 equals 15 over 9. Multiply that, we get 9x equals 15 squared is 225. Divide 225 by 9, and we get x equals 25. Again, rotate it all the way around. Now this one is a hypotenuse or an altitude problem. Notice, because what we're being asked to relate is that altitude 60 with the two hypotenuse segments. So when we do that, even though we are given the altitude, we're still looking for that corollary that relates the altitude to the two hypotenuse segments. So we get 25 over 60 equals 60 over x. 25x equals 3600. Again, I don't have my calculator on me, but I do know that 25 goes into 100 4 times. There are 36 hundreds, so I'm going to go 36 times 4. And I am going to get 144 as my answer. 20, same idea. We have an altitude problem. So we have 9 over 12 equals 12 over x. Cross multiply, 9x equals 144. Divide both sides by 9. And we get x equals 16. So the next couple have big numbers. And that sucks, but it doesn't change how we do this. What does change? So here, this is a red triangle problem. So that's great up until the fact that we realize we don't know what AC is. But we kind of do. Up before, when we didn't have AC, we had two numbers we could add together. The fact that one of those is an x does not change how we do this. We just now have 196 plus x. So if I have 196 plus x over 700 equals 700 over 196. So when I cross multiply, I get 196 times 196 plus x equals 700 squared. That's 490,000. Okay, now I'm going to do something a little different here. Instead of distributing that 196, I'm going to divide it by it right away. Doesn't actually change your answer, I just find it easier. So it's going to be 196 plus x equals whatever that number is, 2,500 minus 196. That is 2500, not 2506. And so our answer is 2304. Move on. So now here we have same general idea. Our A to C, our hypotenuse, the original hypotenuse of the big right triangle, this measurement right here is 81 plus x. So we go 81 plus x over 369 equals 369 over 81. Gives us 369 squared equals 81 times 81 plus x. 369 squared is 136,161 equals 81 times 81 plus x. Again, I'm going to divide both sides by 81. I am using my calculator now. I cannot do this in my head. So I get 1,681 equals 81 plus x. Subtract 81 from both sides. And I get 1,600 equals x. Okay, again, important. Go back and look at some of these more basic problems that we did up here. Notice the process by which we did it. Specifically, let me back up. Look at 14. Okay? Then the only difference between 14 and 21 and 22 and 23 is that we just use bigger numbers, okay? The process is still the same. That's what's great about math. Even though we're getting more complex, we're using the exact same process. We add 4 plus 3 together, we're using the same thing as when we add, a 6-digit number to a 4-digit number. It's the same process. We just have to do it a little bit more precisely because there's more room. The more we do something, the more room for error we introduce. So we just got to slow down, trust that we know what we're doing, trust that we know how to do our maths, and move forward. 23. Here we have, oops, I went back a little bit too far. So 23. Our hypotenuse, our AC, is 400 plus x over 580 equals 580 over 400. So this is going to give us 336,400 equals 400 times 400 plus x. Okay, so again, I find it easier just to divide both sides by 400 right away. Plug that into my calculator, I get 841 equals 400 plus x. Subtract 400 from both sides, and I get x equals 441. Now I'm going to go ahead and do it the other way just to show you that it can be done and that you'll get the same answer. So here, now again, if I'm doing it right, I should get the same answer. So now, instead of dividing by 400 right away, I'm going to distribute that 400. So I get 400x plus 16,000. That's 400 times 400. I'm sorry, 160,000. Subtract 160,000 from both sides. And I'm going to get 176,400. Now that's equal to 400x. So now, just into my calculator, I'm going to take that 176,400, divide by 400, and if I'm lucky, everyone all at once, x equals 441. Okay, so it does work. See, it's the same thing. 441, 441. Check my work. It's good. So 24. Same general idea. We're going to go 900 plus x over 1,500 equals 1,500 over 900. Again, this is a red triangle problem. They all have been recently. 1,500 squared gives me 2,250,000 equals 900 times 900 plus x. So now I'm going to divide 2.25 million by 900. And I get the nice easy number of 2,500 equals x plus 900. So I'm going to subtract 900 from both sides. And I get 1,600 equals x. Easy peasy. Okay, again, if you get stuck, go back, look at it. All of those, and they were either altitude or red triangle problems. For some reason, the program I used to generate the questions doesn't like a whole lot of blue problems. Anyway. So, 25. So now we're getting into similarity in one triangle. So we're going to be using the side splitter theorem, the corollary to the side splitter theorem, that's when we have the ladder looking things, and the angle bisector theorem. Now both of these say that when you apply them, that you are applying proportionality. So 25 is a side splitter theorem. It says if a line which is parallel to a side intersects the other two sides, so let's check, make sure we have that. Parallel, intersects two sides, check and check. And it looks kind of like a little face, see? These are glasses, so it's not like he has two noses. Say hello to Mr. Triangle. See, I'm Mr. Triangle. There you go. Okay. going to relate those two. So I'm going to go 12 over x plus 5 equals 8 over 10. Now notice here, if I had decided to go left to right instead, so compare these two right here, what would happen is I would end up with 12 over 8 equals x plus 5 over 10. Either way, when I cross multiply, I'm going to end up with the same thing. 12 times 10, or 120, equals 8 times x plus 5. And again, multiplying across the triangle. It's a good check to make sure you're doing it right. That's going to give me 120 equals 8x plus 40. So then I'm going to just subtract 40 from both sides. So I get 80 equals 8x, or x equals 10. Now I am asked for the missing length, so I go back, plug in that 10, and I get 15. Okay. 26, repeat. 15 over 3 equals x plus 12 over 4. Now I'm going to make my life easier here by reducing. So we get 5. 15 divided by 3 is 5. X plus 12 over 4. Now I just treat this like a regular algebra problem. Multiply both sides by 4. I get 20 equals x plus 12. Subtract 12 from both sides, and I get x equals 8. 27, same general idea. And again, I could go 12 over 2x plus 2 equals 6 over 4. Get the same answer. So 12 over 6 here divides to 2. So I have 2 equals 2x plus 2 over 4. Multiply 4 by both sides, and I get 8 equals 2x plus 2. Subtract 2 from both sides, I have 6 equals 2x. Divide by 2, I get x equals 3. Make sure you go back. See, now if I had done that, 12 over 2x plus 2, just going to show you it works the same way, equals 6 over 4. 12x plus 2 equals 3 over 2. I'd rather multiply by smaller numbers, it makes my life easier. Cross multiply, 24 equals 6x plus 6. Subtract 6 from both sides, divide by 6, and I get x equals 3. Check. Okay. So make sure you go back, plug in your x's. So for 26, we get x plus 12 equals 20. For 27, we have 2 times 3 plus 2, or 6 plus 2, or 8 is 8. Okay, so make sure you answer the question. Says find the missing length indicated. 28. So here, so for 28, I need to break it down a little bit because I can't match up without the appropriate measurements. So I match up this side to this segment, this side to this segment. Well, we didn't have that segment. But we did. We know that the total length of that side was 32. The given side was 12. The given segment was 12. So we know that the rest of it had to be 20 because 20 plus 12 equals 32. Or 32 minus 12 equals 20. So now we set up our proportion. We're going to go 20 over 25 equals 12 over 2x plus 3. I did a raise because I wasn't sure it was a 3 there. So 20 over 25 reduces to 4 over 5. We're now going to cross multiply. That's going to give us 60. 5 times 12 equals 4 times 2x plus 3. Distribute that 4. We get 8x plus 12. Subtract 12 from both sides, and we get 48 equals 8x. Divide both sides by 8. And we get x equals 6. Plug it back in. 2 times 6 is 12, plus 3 is 15. Don't forget to plug it back in. If this is a question worth 4 points and you only put x down, you will get no more than 3 points, possibly only 2, because you only did half the problem. 29. So again, here we need to find that missing length. So we're going to go 4 over 3 equals negative 2x plus 2x, or negative 2 plus 2x over 6. Cross multiply. We get 24 equals 6x minus 6. Add 6 to both sides. We get 30 equals 6x. Or x equals 5. Number 30 now, notice there I forgot to plug x back in. Don't worry, at the end of the slide I will go back and do so. So, find my missing length 3. Set up the proportion. Notice here we have 12 over 3 equals 4. Now here I end up with my 2x minus 5 in the denominator. So I'm multiplying both sides by 2x minus 5. That's giving me 8x minus 20 equals 20. I'm going to add 20 to both sides. Gives me 8x equals 40. Divide both sides by 8. We get x equals 5. So notice now I'm going to go back, plug in my variables, and solve for the missing lengths. So over on that left-handed one, I got 8, and on the right-hand one, number 30, I got 5. So, same general idea on the next one. We get 20 over 12 equals 10x minus 5 over 27. Reduce 20 over 12, we get 5 over 3, factored out of 4, equals 10x minus 5 over 27. Cross multiply, 27 times 5 gives us 3 times 10x minus 5 equals 5 times 27. 30x minus 15 equals 135. I'm going to add 15 to both sides. I could have divided by 3. I just decided not to. 30x equals 150. Divide by 30. I get x equals 5. Make sure you go back, plug it in. 50 minus 5 equals 45. On to number 32. Again, solve for that missing length. 27 minus 12 equals 15. Cross multiply. But we're going to set it up just to make sure. 25 over 15 equals 12 over 4x. 25 over 15 reduces to 5 over 3. And hey, 12 over 4x reduces to 3 over x. That gives us 9 equals 5x. We're going to divide both sides. I want to make sure I'm doing this right. So notice what I did up there is I went back and did the unreduced version just to make sure I'm doing it right. Divide both sides by 5 and I get x equals 9/5 or 1.8. Okay, almost there. Okay, so these, we already know these polygons in each pair are similar. Okay, find the scale factor of the smaller to the larger figure. Now here we want to make sure when we set it up, we're setting it up right. So we want to make sure that we are relating short to short equals long to long. Okay, and that's going to give us our scale factor. So here our short on the bottom one is 8, short on the top one is 20, 14 over 35. Now in all fairness, because we're already told that these are similar, we could just do 1. I like to do 2, set up that kind of proportion instead of just using it as a ratio to find the scale factor, just to make sure. I like to double check my work. 34. Now notice here, it's kind of flipped around. So the 18 and the 6.1 don't match up. How can you tell? Well, look at the shape. See right here, this is the one leaning to the right, and here it's been flipped around. That's leaning to the left. So when we set this up, we relate the 7 to 21 and then the 6.1 and the 18.3. If you don't do that, you're not going to end up with 1 to 3 as your scale factor. Okay, because then you'd have 6.1 to 18, and that's not a thing. And you'd end up going, hey, those don't work together. They do. Well, not the 6.1 and the 18. Those don't work together. The 6.1 and the 18.3 do. Moving on. Just got 2 more slides. So exciting. Now this one, this is an isosceles triangle. So you're just going to go 8 to 8, 16 to 16. It's the same thing, so you just go 8 over 16, 1/2, or 1 to 2. Remember, we're going small to big. So, moving on to the next one. So here we want to make sure that we're matching up the right ones. So I'm going to go short to short, long to long. Now notice, even though we have two 10s here, the 10's the short one, and the 25's the short one. So don't sit there and go 10 over 35 equals, 2 over 7. Okay? So what we're going to do here is we have 10 over 25 equals 14 over 35. Again, you really only have to do 1. I like to do 2 just to make sure I set it up right. If I'd set it up wrong, let's say the other way, I'd have 14 over 25, nothing reduces, equals 10 over 35, 2 over 7. So I'd sit there and go, hold on, 2 over 7 doesn't equal 14 over 25. I must have done something wrong. If I had only done one of them, I'd end up with the wrong answer, either 14 over 25 or 2 over 7. This way I factor out a 5, factor out a 7, and I end up with 2/5 for both factors, so that's going to be 2 to 5. It's going to be the ratio. Same general idea for the next one. I'm going to go 8 over 16, 1 over 2. Now notice here, after I just spent an inordinate amount of time saying don't do just 1, here I can only do 1. Okay, because notice the 7's going to match up with this side right here, no measurement, and the 4's going to match up with that side right there, no measurement. So even though I'd love to do multiples, because I only have 1, I can only do 1. Same thing here. The 15's going to match up right here, and I have nothing to match up with 32. So my scale factor is 15 over 20, or 3 over 4. So to say 3 to 4. And you know what? That's it. So good luck with this. Hope this made sense to you. If you guys have any questions, please ask. Now remember, this is a guide, but I also reserve the right to ask questions that were on other assignments. So make sure that you got those down, turned in, and ready to go. Have a good evening, everybody. I'll see you guys tomorrow.